This next case is what we in the biz called a IVP, a initial value problem. Initial value problem is a fancy way of saying that we're going to give you that y of 0 equals 17 and ask you to find the constant. But we want to show, first we want to do something similar to the previous problem, which is that we want to show that this function y equals 13 plus 13x plus c e to the x is a general solution of the differential equation y prime equals y minus 13x. And it bears mentioning that in a regular equation, we always want to solve for x. In a differential equation, we're actually solving for y. We want to find the function y that satisfies this differential equation. Now, in this case, they're giving us the function, giving us the answer, and asking us to test it out that it actually works. So let's do that. Now, once we do part A, then we go to part B, which says find the constant c, that constant right there, given that y of 0 equals 17. And this is called a particular solution. A is the general solution, and B is going to be a particular solution, which is constraint with the constraint, given the constraint that y of 0 equals 17. Let's see how this. Let's do A, which should be familiar to us. So first thing I want to do is I have y. I want to figure out y prime just by taking a derivative. Then I'm going to take my y and my y prime and just substitute them into the original differential equation right there. And when I do that, I'm going to get y prime is 13 plus c e to the x, which I get from this line right here, equals y, which is 13 plus 13x plus c e to the x, which I get from right there, minus 13x, and I just bring down the minus 13x. Now I just solve. Basically, all that's going to happen is that the 13x and that 13x is going to cancel, and I get this, which is obviously true, because 13 plus c e to the x equals 13 plus c e to the x. So yes, this was a solution because it all worked out. Yay for us. Now let's go to part B. In part B, we're plugging in, we use the fact that y of 0 equals 17, which means that if I plug in 0 for x, I will get 17 for y. So I'm plugging in 17 for y, I'm plugging in 0 for x. I want to see if this, and then I want to, now I can't see it, I'm not checking to see if this works out because I don't know the value of c, but I want to find the value of c that's going to make this work out. So this just gives me 17 equals 13 plus c. Why is that? Because 13 times 0 just disappears. E to the 0 power equals 1, so it's just c times 1. So I get 17 equals 13 plus c, and even I have enough fingers and toes to realize that c equals 4. And so if we want to find c, that's c. Now if I would ask you to find the particular solution, that just means what would y look like when I plug in my value of c, and that's my particular solution to the differential equation. Y equals 13 plus 13x plus 4 e to the x. And all I did was I just plugged in 4 for the constant, and this would be the particular solution. Remember, there are infinite general solutions, but only one particular solution for a given restraint. Now, of course, I could if I set y of 0 equal 18, I would have a different. I would get a different c if I get, and so on and so forth. But this is for any particular constraint, I get one solution only, as opposed to the general equation. I can get an infinite number of solutions, what we call a family of solutions, infinite family of solutions, because c could be anything. And that is how we do that.